Hello. In this video, we're going to look at the unit circle, and you'll see how you can complete the unit circle quickly and easily with very little memorization. Okay, first of all, one of the things that you need to remember when we're working with the trig functions are your basic definitions. So I wrote them here, that the sine of theta is opposite over the hypotenuse, the cosine of theta is adjacent over the hypotenuse, and the tangent of theta is the opposite over the hypotenuse. And now I'm going to take a triangle, just a general triangle, and I'm going to put it in the coordinate plane. So if this is the case, and let's say here's my triangle, right here, it's a right triangle. Here's my theta, and if this is my hypotenuse, this is my opposite from theta, the side is opposite, and this is adjacent. So then I can think of my definition of sine as my opposite. I can also see that as, since it's opposite, it is the y value. It's parallel to the y-axis. So I can think of this as y. This is along the x-axis, so I'll think of this as x. And this, when we're talking about it in the coordinate plane, is going to be called r. And again, you see Pythagorean theorem that x squared plus y squared equals r squared. So when I look at my definition, then I have that the sine theta is opposite over the hypotenuse. I can think of this as y over r. My cosine is adjacent over hypotenuse, so that's going to be x over r, and my tangent is the opposite over adjacent, so that's going to give me y over x. So those are the definitions that I'm going to work with, or the way I'm going to redefine sine, cosine, and tangent to work with the unit circle. And here is my unit circle, and a unit is 1. So in this instance, when we're referring to the unit circle, we're referring to a circle whose radius is 1. So when my radius is 1, I'm going to focus in right now on 4 particular points, and these are the quadrantal angles. It's this point, which we know the coordinates of this point. Since this is 1, this is going to have the coordinates of 1, 0. This has the coordinate of 0, 1. This is the x value, this is the y value. Okay, this is nothing new. This is basic algebra. Okay, over here, the coordinates from the origin, it's -1, 0. And those coordinates, again, are x and y. There's your standard xy coordinates. And this has the coordinates of 0, -1. I'm writing the x and the y for emphasis, but you already know what those are, x and y. Okay? So that's algebra 1. We just labeled those four quadrantal angles. Now we also know when we are labeling the angles, this is 0 degrees, and this is a 90-degree angle. So right here we have 90 degrees. Over here is 180 degrees. And here is 270, and I'll put it right here on the side. And over here we can also call this 0 degrees. We can also call it 360. So that's why we say a 360 is a whole complete circle. So we end up where we started. That's one circle. Okay? We have our points labeled. We haven't used anything tricky. But now if we want to know let's say the trig functions, like let's say I want to ask you for the sine of 0 degrees. That's right here. So the question is sine of 0 degrees. So it's right here. By definition, it's y over r. So the sine of 0 degrees is the y value, which is, it's labeled 0, and r is 1 for all of these problems, so 0 over 1. So the sine of 0 is 0. If I want to find the, let's say the sine, or the cosine of 180 degrees. Okay, so that's going to be right here. The cosine, by definition, of 180 degrees is x over r. The x coordinate is, the x value of cosine of 180 degrees is the x value, which is -1. R is 1. And there's my answer. The cosine of 180 degrees is -1. Well, let's say we have a question about the tangent. And I want to know the tangent of, let's say, 90 degrees. So if I have the tangent of 90 degrees, tangent by definition is y over x. The tangent of 90 degrees is, the y value here is 1. The x value is 0. So we have that the tangent of 90 degrees is undefined, because we can't divide by 0. And so we can find the value of any of the three, or we'll just use the definitions for the other three if that's what we need to find. But we use our definitions in terms of x, y, and r, and we'll work with the quadrantal angles, and we can come up with the value of any of those trig functions. I'm going to erase the work I just did, so we'll look at, because there's a few more angles that we worked with for the unit in the unit circle. Okay, in addition to working with the quadrantal angles, the unit circle also involves the two special right triangles. And you'll see how the relationship was developed by looking at those videos. I have a video for the 45, 45, 90, another one for the 30, 60, 90. So here I just drew in the angles. This one is half of a square, and this is half of an isosceles right triangle. This is half of an equilateral triangle. So if I want to find in here, because it's a unit circle, the radius or the hypotenuse here is 1. So let's say using this, if I had to find for the 45-degree angle, it's going to be right in here. And I just drop it down. There's my relationship. And the hypotenuse is 1. This is the square root of 2 over 2. And the y value is the square root of 2 over 2. So if I'm going to find, let's say, the tangent of 45 degrees, I have y over x, which is the y value is the square root of 2 over 2, over the x value, which is the square root of 2 over 2. And initially you look at that and it looks intimidating, but you realize it's just equal to 1. So we know that we can write that the tangent of 45 degrees equals 1. So we can put our angle, our 45-degree angle, it's going to be the reference angle if we place it over here. Or we can put it over here, and it gives us a reference angle of 45 degrees. We have our relationship between the sides. The hypotenuse is always 1, and we can place the angle wherever it is. But when we put it over here, the x-coordinate is going to be negative. over here the x-coordinate and the y-coordinate is going to be negative. But that's not trigonometry. That's basic algebra, because you know that when you go to the left, it's negative, and when you go down, it's negative. So you just put the special right triangle in whichever quadrant it is. So then you can go ahead and find the value of the trig function. The same thing works for the 30, 60, 90. If you wanted to, let's say you wanted to find the cosine of 150 degrees. Well, here's my quadrantal angle, 180. So we know that 150 has the reference angle of 30 degrees. So when I go to draw it in, my hypotenuse is 1. The one opposite the 30 is the 1/2. And the one opposite the 60, which I didn't write in because it doesn't really fit, is going to be the square root of 3/2. But because we're going to the left, then it's going to be negative. This is positive 1/2 because we're going up. So we don't have to worry too much about the sign because it just goes back to our basic algebra. We're not using trigonometry to find the sign, which is using basic algebra. So here, my question for the cosine of 150 degrees, I'm going to think of it as 30 degrees. And so I'm still going to use the x over r definition. My x value is my x value is negative square root of 3/2, and my y value is 1. So then my answer is just going to be negative square root of 3/2. That's the cosine of 150 degrees. So I've used the reference angle, and when they're working with the unit circle, they're only going to work with the 4 quadrantal angles, the 30, the 60, and the 45 degree angle. So you just take your triangle, your basic triangle, and you think of it as moving it to wherever it is that they want it to be. I find it very helpful to just draw it in. I'll just draw it wherever it is. I relabel it, place the signs on it first, and then I can use the appropriate definition, and I can find any of the values of the trig functions without memorizing anything. Because this we know, that's from our geometry, and if we forget, then we use the Pythagorean theorem and figure it out. The quadrantal angles, basic algebra, the value of the signs, whether it's positive or negative, basic algebra. So it's not sophisticated trigonometry that you're using. We just, when we see it completed with all the angles all over the place, it looks intimidating. But take it one angle at a time, move the triangle to where it should be, and you can figure out anything. I hope this helps.